Assalamu alaikum. In this video, we will discuss about a PID-controlled line follower robot. Hello everyone, I'm Ghazi Hassan Ishraq and I'll be talking about the body design of the robot. So for the main body of the robot, I have used a custom 3D object which I designed it in Vectory, a 3D web application software that you can use to design any 3D objects. It's a pretty simple object. So later on, I've saved this and downloaded this and imported this in Webots and use this as the main body shape of the robot. I make sure that the axes were perfectly centered with the body. And I've attached 4 hinged parameters in the foreside of the robot as for the wheels, and it has rotational motor devices at the end, and for the end effectors there are wheel shaped objects at the end. I wrote also a simple code to test that the wheels were moving in the right direction, since due to the axis in our cases we had to use the negative speed value so that the robot actually moved forward. In other cases it could be some other value for the robot to move forward. It basically depends on the axis and the robot position in the world. So we had to run a few tests and to to come to a conclusion where the robot would move in the right direction. For the sensors, we have used 3 distance sensors which are IR type sensors, and I make sure that the sensors were pointing downwards because it needs to read the line, and some cases we had to shift it and tweak it a bit so for the accurate results. So that's it for me. Thank you.
Hello, I am Aburayan Shakil and I will be describing the PID controller of our project. Firstly, from controller we have imported robot. The time step is 32, that means in 1 second 32 positions will be fed. The robot is initialized. There are 4 wheels, so 4 motors. And the initial position of the motor is set infinity because initially we do not know exactly the position. The motor velocity is set initially 0. From here, the PID part is started. Kp, Ki and Kd are proportional, integral and differential constant. These are put manually and then tuned. The error is 0. The error is used to decide whether to turn right or left. The base speed is 3 minus 3, which is also put manually and then fed into the motor. The last position is to deal with the situation like this, when the robot is out of the track and cannot decide whether to turn left or right. It will regain its last position and then decide whether to turn left or right. There are 3 different sensors and hence 3 different IR values. These values are put less than 280 because after we ran the robot, we saw that after if the value is less than 280, the robot is on the track. So this part, when it is greater than 280, the value will be 1, 1 and 1. Then there will be some values of weight because these values will not be 0 this time, and the sum will be not equals to 0, so it will come here and calculate a new position, and the last position will be the new position, and this will be used to calculate the motor correction. The motor correction is the most important part of the PID, and see here the last position and last position is calculated and multiplied with the KD value that we have got after the tuning Ki into position, because this part will be used to turn the robot into its right position, and Kp is proportional to its position. The motor correction will be now added or subtracted with the basic speed, which is put manually minus 3, and this will help the robot to maintain its track.
Hello, I'm Tahira Khanum Tine. Now I will be showing the simulation and the mechanism of our robot. Here we can see, using Tinkercad we have created the track for our robot with multiple lefts and right turns. And then we have imported the track in our project. As we can see the track right here. We have implemented 3 distance sensors which are emitting the rays to detect the given path. The distance sensors are actually generating the IR sensors by which the robot is actually being able to detect the path correctly. Now if we start the simulation, we can see the robot is following the path correctly. This is happening because of the PID controller. To avoid any kind of oscillation or shakiness, we have implemented the PID controller. The PID controller uses the 3 control terms of proportional, integral, and derivative influence on the controller output to apply accurate and optimal control. To implement the PID, we needed to adjust these 3 values according to our robot. Now, whenever the robot is taking any turn left or right, the turning position value is less than the other positions. Now, if we again start the simulation, the robot is taking left turn and we can see the left value is less than the other position values because the robot is leaning on the other positions. Even if we move the robot outside the path, for the PID controller, the robot will be able to detect the path and follow the path correctly. If we start the simulation, we can see here the robot is following the path. This is all. Thank you.